The region has been in a moderate drought since mid-August due to the lack of significant precipitation. In August, the total precipitation was just over half an inch, down 2.82 inches from the 30-year average. Frequent rains did return to the region in September, but the precipitation was still half of an inch down from 3.38 inches. Although we had a surplus of moisture in spring, the total precipitation received from April through September was 26.77 inches, down 8.01 inches from the 30-year average. There are several reasons behind the cause of the drought, but the main culprit is the position of the jet stream. The jet stream is a channel of fast-moving air in the upper portion of the troposphere that helps in the formation and transportation of the low-pressure cells that bring us our precipitation. The meandering effect of the jet stream also determines the position of warm air and cold air. As the jet stream bends toward the north to form a ridge, warm air fills in just south of the ridge. When the jet bends toward the south to form a trough, cooler air fills in on the northern side. Precipitation most often occurs east of the trough where the low pressure is situated at the surface. In spring, the jet stream is most often positioned over the south due to the northern hemisphere being partially tilted away from the sun. As summer approaches, the northern hemisphere tilts toward the sun, allowing the jet stream to migrate further to the north. Once summer turns into fall, the northern hemisphere begins to tilt away from the sun, allowing the jet stream to once again migrate south over most of the United States. The jet stream in August had two troughs positioned over the northwest and northeast United States, while a persistent ridge stayed to the north of the Great Plains. With the jet so far to the north, the southern third of the United States has continued to suffer significant drought conditions that plagues farmers of many crop types, including peanut farmers. Another culprit behind the current drought is the persistent heat influenced by the lack of significant moisture in the soil. Soil moisture influences the overall surface temperature of a region. When there is moisture available in the soil, temperatures will moderate slightly. However, when there is not enough moisture in the soil, daytime temperatures can soar as they did in August and the beginning of September. The dry soil increased the surface temperature, which increased the drying effect of the soil. It is similar to putting a chicken in the oven without water and watching the chicken dry up because of the heat. Dry soil also leads to dry air or very low dew point temperatures. When rain does move in, it is difficult for the rain to actually reach the surface because the air just above and at the surface is dry. The result is precipitation evaporates before it reaches where it is needed. In order for rain to make it to the surface, a significant amount of precipitation is needed to saturate the air above the surface, and hopefully by that time there is still plenty of rain to fall to soak the soil. There were many hopes of rain soaking the soil in August, but the soil was too dry and the chance of precipitation dwindled. If you thought those reasons were enough, get ready for just one more. With dry soil, hot temperatures, and the position of the ridge, winds also increase drought conditions. Winds typically increase during the day when the sun rises and increases the energy received at the surface. Without significant soil moisture to moderate temperatures, the winds increase, further drying out the soil if any moisture is left. Not only does the soil dry out with windy conditions, the crops also help in drying out the soil. Crop plants like corn and beans pull moisture from the soil and release that moisture through their leaves called transpiration. Windy conditions increase plant transpiration that results in doubling the drying of the soil. If we could have reversed the drought situation back in August, we would have needed the jet stream to shift further to the south with the east side of the trough over the Midwest and the amount of precipitation to remain within the 30-year average. However, what we always want will undoubtedly turn against us.